How's it going, everyone? I so wish that we could be together in person. This is just not going to do it justice, but I appreciate the organizers of this conference for allowing some of us to do presentations virtually. I hope that this presentation will be valuable for all of you, and I very much look forward to seeing all of you in real life very soon. This whole coronavirus thing has thrown a wrench into many lives. And I think that perhaps my greatest sadness, or one of my great sadnesses this year, has been that I don't get to see any of you in person. There are a lot of high fives to be given. There are a lot of hugs to be given, a lot of ideas that we should be sharing in person, but we'll do Zoom. So let's get on with it. I've got a lot of slides, and I don't want to take up too much of your time. I think these online presentations get a little bit onerous if they go too long. As all of you will know, I have a penchant for long-windedness. I will do my best to be succinct and to deliver all the goods as quickly as possible in this presentation. So thanks for joining me. Let's get started. Here we go. So my talk is debunking the carnivore diet. Perhaps some of you have heard about this crazy thing called the carnivore diet. And let me tell you, it's bonkers, and I'll tell you why in this talk. So here we go. I have a few disclosures. I wrote a book about the carnivore diet, and I eat meat. My book is called The Carnivore Code. So clearly I'm being facetious, and I'm going to try and show you why I believe that a carnivore diet is a viable diet for humans, why animal-based diets in general are incredibly beneficial for humans. And I'm not going to be debunking the carnivore diet at all, though I will take many of the positions that those who try to criticize a carnivore diet and show you why I think that they don't hold up under scrutiny. So this is my book, The Carnivore Code. All of my controversial thoughts can be found in this book. If you are listening to this talk in the middle of June or July, this book can be found on I'm trying to, no, don't do that. Go back, other way, smaller, there we go. All right, sorry guys. This book can be found on Amazon, thecarnivorecodebook.com. The second edition of the book is now available for pre-order. The first edition, which is the cover you are seeing here, is no longer available. That is a collector's item, my friends. The second edition of my book will be released August the 4th in Audible, audiobook, ebook, and print. Go to Amazon to pre-order it for more of my controversial thoughts. What is a carnivore diet? Let me tell you. The technical definition of a carnivore diet might be all animal foods excluding plant foods. Well, I think we could also get a little bit more broad and think about a diet that emphasizes animal foods and pays attention to a spectrum of plant toxicity and call that a carnivore-ish type diet. So I am interested in results over dogma, and I think that what we will find generally is that if we emphasize animal foods in our diet, we will thrive. And if we think about a spectrum of plant toxicity, we will also find great improvements in many of the things that sometimes Western medicine doesn't do such a great job of treating. So we will talk about a spectrum of plant toxicity today, and we will also talk about why the heck you should emphasize animal foods in your diet and make them the center of your diet. Isn't that completely contrary to what we're told in the Western world? We'll find out. So why would anyone do such a crazy thing? Let me answer that question for you, my friends. There is very intriguing evolutionary evidence for meat consumption by humans for over 2 million years. But wait a minute, aren't plants good for us? What about phytonutrients, polyphenols? We'll dig into that. Don't we need fiber for a healthy gut? We'll talk about it. Doesn't meat cause colon cancer, heart disease, shortened lifespan? It's on the list for today as well. And finally, we'll talk about why cows may or may not contribute significantly to climate change. But all of these points would debunk the value, the veracity, the intentions of a carnivore diet. And in fact, what I'll be doing is debunking the debunkers of a carnivore diet in this talk and in my book. Let's start with a little bit of story about me. This is me. This is Vegan Paul, circa 2009. This is really one of the best photos I have. My hair was longer, and I smiled, but I weighed 30 pounds less of muscle. Right now, I'm 175 pounds, about 8% body fat. In 2009, I was 140 pounds on a vegan diet. So lots less muscle. Now, Carnivore Paul, circa 2020, clearly has end-stage polyphenol deficiency. And this is what end-stage polyphenol deficiency looks like. So that's the end of my talk. Thank you very much. I think we've proved our point here today, and you can all get back to living your lives. If you would like more details, you can stick around for the appendix of my talk. This is the epilogue. So that's my talk, and we can move on to the epilogue. So in my days of medical school, which is what this photo is from jiu-jitsu, I had pretty bad eczema. I had my own autoimmune disease. I had a disease on my skin that was pretty frustrating, pretty difficult to handle for me. And I knew that somewhere it was probably related to the foods that I was eating. What was it about the foods that I was eating that were triggering my eczema? At that time in my life, I was organic paleo, and I just started cutting out more and more foods. I got pretty close to a carnivore diet when I would cut out all the oxalates, when I cut out all the phytoalexins, when I cut out all the lectins, when I cut out all the histamine-producing plants, when I cut out all the salicylates, closer and closer to carnivore. But I thought, oh, I need those polyphenols in my diet. I must have them. Surely they're valuable. Eventually, I just took the plunge and completely eliminated all plant foods. And lo and behold, a couple weeks later, my eczema completely resolved. It was much easier to live my life. And I felt way better in general. Had an improvement in my psychological overall perspective on life, and haven't looked back. It's been about 2 years since then. And as you can see, in 2020, I have a pretty bad polyphenol deficiency. Just want to show you guys my jiu-jitsu face. Some comic relief at the beginning. And at the beginning of all these talks on a carnivore diet, let's just answer the most important question. I pooped today, and it was beautiful. We'll get to the fiber part. No, you don't need fiber to have beautiful, regular bowel movements, I promise you. And this is an actual picture of my poop from today. It was golden. I have a new business opportunity. So what are we about? We're about cracking the code. My friend Tommy Wood, I was lifting with him one time, and he said, what about the carnivore code for your book title? And I thought, that's a good idea. So what's the code? Well, the code is clearly how the heck do humans eat to be as good as possible? How do we kick as much butt as possible? So we want to crack that code. Let's talk about a postulate for the ideal human diet. I think it would contain all the nutrients that humans need to thrive in the most bioavailable forms without any of the anti-nutrients or toxins found in plants. Or let's just say with the fewest amount of toxins and anti-nutrients. I won't even say in plants. And if you accept that as a reasonable explanation of an ideal human diet, we'll move forward and we'll see how we all answer that. But I believe that is an interesting code that we are all trying to crack. So where have we come from? Let's start at the beginning. Again, this is pretty similar to the stuff I talk about in my book. If you want more detail, the carnivore code is what you want. Read my book. I'm not an anthropologist, but I've gone to great lengths to understand this stuff, and I find it quite fascinating. Many conversations with anthropologists. As far as I can tell, we became humans somewhere around here, 2 million years ago, in terms of Homo genus. But, the species, we don't know. Before that was Australopithecus, which wasn't quite human. Australopithecus was about 4 million years ago. There's Homo habilis, Homo erectus from about 2.8 million years ago. And Homo sapiens for about 350 to 300,000 years, looking pretty similar to the way humans look. Maybe Homo heidelbergensis. If you saw Homo sapiens from 300,000 years ago on the street, you might just think they were an MMA fighter or something. They look pretty normal. And even back 2 million years ago, we were starting to look pretty hominid. So this is where we've come from, but way back before this is millions of years. 30, 40, 50, 60 million years of primate evolution. What was the change? Where did the change come from? What happened? This to me is a fascinating graphic from my book, Primate Ancestors back here millions of years ago, Australopithecus 4 million years ago, Homo habilis 2 million years ago. Look at this change in the human brain size. Boom, right there. And modern humans, 1500 cc, 1400 cc, up from, down from an apex of 1500 cc. But what happened here? What caused this massive turn in the size of the human brain? Many people theorize, but I really think it's pretty clear it was hunting. It was the sudden inclusion of lots of human hunting in the lifestyle, the inclusion of many animal foods in our diet, which provided unique nutrients, which are myriad, which we will talk about later, unique animal-based nutrients in our life. And these are, I believe, what allowed our brains to grow, whether it interacted with certain genes like Notch, or our brain was just waiting for more B12 or more bioavailable food so our guts could shrink. We don't know, but as far as we know now, fire was much later. Doesn't seem like fire corresponds here. There's a famous anthropologist, Richard Wrangham, who suggested that it was the use of fire for meat or the use of fire for calories from tubers that allowed our brains to grow, but I think it was hunting. And I think there's a lot of evidence for that it was the inclusion of animal foods in our diet in much greater amounts 2 million years ago that was this magical catalyst that made us into who we are today. An incredible species. We don't always seem to make great decisions, but we're pretty smart and resourceful. So what gives us evidence that there was this hunting now? Stone tools. There are these Acheulean tools from 1.8 million years ago that look just like this. A bifacial tool that showed up right about that same time as human brains getting a lot bigger. Looks like a big arrowhead. This is meant to be held in your hand. There's also evidence for butchering, cut marks on bones. It's a tapir, and it's from Florida, showing butchering marks. So we see these stone tools and evidence that we were using them to hunt and cut the bones of animals. This is not a hunting mark. This is a butchering mark on the bone. We were eating animals, you guys. We were eating animals. And our anatomy really speaks to that as well. Our rotator cuff, chimpanzees can't throw a fastball like we can. Pelvic girdle, hand and feet, the sclera of our eyes, the acidity of our stomach, and this trade-off between the smaller large intestine, the larger small intestine, changing rib angle, and this largely energy-intensive organ, the large intestine, which is shrinking, allowing the brains to grow, and the energetic trade-off known as the expensive tissue hypothesis, which we'll get to in a moment. But the white sclera are fascinating too. I did a podcast where I talked to Bill von Hippel about this. This is an ape's eyes. They have a brown sclera. Humans have a white sclera. This disguises the direction in which the chimpanzees are looking. This lets our neighbors know that we're looking over there at a prey, at a predator, or for group behavior. This could definitely have been an adaptation for group hunting. This is advantageous when chimps and primates are inherently competitive. I really think that when we made this transition to Homo, the genus Homo, we became cooperative. And we were cooperating for survival and cooperating to hunt. The expensive tissue hypothesis is this change in the size of our guts. Changing rib angles equals a six-pack if you can get it. And that allows more energy for our brain to grow. This brain-gut trade-off is fascinating and seen in other species. This is the Peter's elephant nose fish, which happens to have the biggest brain for its body size of any fish known, and also the smallest gut. So this is quite fascinating, isn't it? That even among other species, we see a trade-off between gut size and brain size. The big gut means energetically it's kind of unfavorable to grow a big brain. But if your gut shrinks because you can eat more nutritious, nutrient-dense food like animal foods, then your brain can grow. Not surprisingly, the elephant nose fish is a carnivore. Algae for this guy. So here's my premise. Hunting made us human. Hunting made us human. And I think that we know that from all of these adaptations, that without hunting, we would not be the humans we are today. Hunting made us human. You can pick who you want in this picture. The last time I gave this talk, I joked that this was me. Here's Sean Baker. He's the one getting eaten. I guess he's the bravest one up here. Maybe this is my friend Tommy Wood, depending who's in our tribe. But this maybe isn't exactly what it used to look like, but hunting made us human. And it made us human because we had more access to the most nutrient-rich, bioavailable foods on the planet, animal foods. So there's all of this other evidence from stable isotope analysis, which gets a little bit esoteric. Here we're looking at strontium to calcium ratios of hominin and bovine enamel. And what this paper shows is that the South African early hominins preferred meat, that the ratios of ours look a whole lot like carnivores rather than grazers, that our ancestors were, according to stable isotopes in the teeth and stable isotopes in the bones of Neanderthals and first humans, our ancestors looked a lot more like known carnivores than herbivores, meaning that we were getting the majority of our protein from animals. And we can use this with fossilized remains. Last paper, exceptionally high delta 15 nitrogen values confirm Neanderthals as high trophic level carnivores. Remember that Neanderthals were coexistent with Homo sapiens about 50,000 years ago in Europe. You can see canids, so this would be like wolves, hyena, and we compare that to humans. We find that humans end up, the OAS1 human way up here, even sort of more high on the delta 15 nitrogen graph than a wolf or a hyena, other known carnivores. So we're having more nitrogen, suggesting that we're eating either bigger animals, which wouldn't be surprising if we're hunting those megafauna, or more of them. The thing to think about is that plants really look differently today. This is not what our ancestors saw. This is not what we see when we're in the wilderness. These are domesticated plants that are less toxic than their wild neighbors. This is what the wilderness looks like where I went to residency in Seattle. This is actually a picture I took on the North Fork of the Hoh River. There's not much edible in this picture. And this is one of the most fertile places in the world. What are our ancestors going to be eating? They're going to be hunting animals. Maybe in a pinch, they're going to be eating some of the most edible plants, but it doesn't look like this. You can't just go out and pick a carrot, some broccoli, a potato. There's nowhere near this amount of edible plant matter on a natural landscape. So where did we go wrong? What happened at the end of that graph where the brain size started to shrink? This is paraphrasing something that Jared Diamond said. What is the greatest mistake in human history? Jared Diamond says it was agriculture, the cult of the seed. There's a lot of fascinating analyses at this time in our history, about 12,000 years ago. People like Graham Hancock, Randall Carlson believe there was a meteor, a Younger Dryas meteor impact that may have caused mass megafaunal extinction. Others believe we hunted the megafauna to extinction, and still others like Robert Schoch believe that there are coronal mass ejections. But Randall Carlson, Robert Schoch, Graham Hancock all believe there was a massive change in the availability of humans to get the big animals that we were probably hunting for 2 million years. Problem there is, what do we do in the absence of those? We're kind of stuck. Maybe somebody figured out, hey, we can grow these plants. This is great, except growing plants doesn't turn out to be so good for human nutrition. This is a skull, and we can see here parodic hyperostosis. I believe this is a skull from the Ohio River Valley, right around that time in our history when we see a mass increase, a major increase in the amount of fractures, the amount of tuberculous lesions, the bone quality degrades massively, and we see these parodic hyperostosis lesions. These are spongiform changes in the skull of a human related to nutrient deficiency, specifically iron and other minerals, corresponding with a mass move to agriculture. Maybe not a good thing. Maybe not a good thing to forsake the most nutrient-rich, most bioavailable foods on the planet. We may have been forced to, we don't know, but inevitably we see that there was a pretty significant decline in human health during this Neolithic revolution 10 to 12,000 years ago. This graphic from my book illustrates that. Decline in height, porotic hyperostosis, increased evidence of cavities and tooth decay, tuberculous lesions throughout the body, including the spine, shorter femur lengths, poor wound healing. Bad news. Bad news. Probably the worst mistake in human history. And here we are. So let's just remember also, plants don't want to be eaten. Whenever I say this, people say, well, neither do animals. Well, yeah, but animals can run away or kick you or gore you or bite you. Plants are stuck in the ground, right? This little plant right here can't run away from Diplodocus. So what have plants been doing for 450 million years? Since the time of the dinosaurs, they've been co-evolving defense chemicals. There has been an ongoing chemical warfare happening between plants and animals for hundreds of millions of years. And the idea here is that unless a species is exclusively consuming plants or consume plants as the majority of their diet, they may not be well adapted to these toxins. So if you remember that perhaps it was the eating of animals that made us human, and the animals became the majority of our diet, did we lose or just not evolve ways to detoxify many of the compounds found in plants? I'm not saying plants are uniquely toxic across the board for everyone, only that plants exist on a spectrum of toxicity. And if we're not sensitive to that spectrum of toxicity, many of us will suffer negative consequences because of that. That is really one of the two premises of a carnivore diet. The first is that the first is actually that animal foods are wrongly vilified and have been made out to be villains when they're in fact the most nutrient-dense bioavailable foods on the planet. In this talk, a little later, we'll talk about why they've been vilified and how they've been incorrectly vilified. But the second is that plants exist on a spectrum of toxicity. They contain toxins, and if we ignore this, we will suffer. I don't think everyone on the planet needs to be carnivore, not even close. But if we eat in a way that prioritizes animal foods and understands the spectrum of plant toxicity, I believe we will thrive. Here's the harsh reality. Kale doesn't love you back. Why do we assume that plants are good for us? What if we think about things from a plant's perspective? Plants have a myriad of defense chemicals. These are only a few. Phytoalexins, which is a broad category, oxalates, lectins, salicylates, the list goes on and on and on. This is the chemical warfare that's been going on between plants and animals for hundreds of millions of years. This is just an example of a number of phytoalexins. These are plant defense chemicals. This is our friend sulforaphane. This is a tannin molecule. One of these is curcumin, and I believe the other one is resveratrol. You can see many of them are polyphenolic. Sulforaphane is an isothiocyanate. But interestingly, many of the compounds that we think are beneficial from plants are polyphenols. Well, here's a list of all the polyphenols made in human biochemistry. Yeah, that's not a mistake. Humans don't make polyphenols in our biochemistry. Polyphenols come exclusively from plants. Does this mean they're bad for us? Not necessarily, but it means that they look foreign to our bodies. I just thought this was an interesting observation that I hadn't heard anyone mention when I was writing my book. I asked my friend Tommy Wood, I said, are you aware of any single polyphenol that is made in human biochemistry? He couldn't. I couldn't find any. If any of you listening to this are aware of any polyphenol in human biochemistry, let me know, but I haven't found a single one. There are many molecules in plants that can mimic human molecules, usually for the detrimental effect, specifically xenoestrogens, but our molecules are not polyphenolic. So isn't this an interesting idea that perhaps the plant molecules just look very different than ours? This is the concept of different operating systems that I discuss in the book. If plant molecules are different than ours, intrinsically, because plants are a completely different kingdom, we've been evolving differently for 500 million years, and plants have been trying to create chemicals to dissuade animals, fungi, insects from eating them. Isn't it reasonable that they could be bad for us? It's just a question. And things start to look very differently if we approach it from that perspective. So phytoalexins are plant pesticides, except not the kind that you spray on plants. These are the kinds that are made by plants. Here's a paper from Bruce Ames. Dietary pesticides, 99.9% all natural. 99% by weight of the pesticides the American diet concludes are produced by plants in and of themselves. Only 52 natural pesticides have been tested in animal cancer tests, and of those, half are rodent carcinogens. Those known 27 are present in many common foods. Do we know for sure these are harming us? No. Should we think about this? I think so. Do we need them in our diets? I don't think so. I don't think they do anything good for us. And of course, many of these animal cancer tests are high dose, but could low doses be harmful as well? Yes. What if we just shift the whole perspective and think about plant foods as potentially trying to harm us? Then everything shifts and we think, well, why would we eat something like that unless we needed it? And I don't think we do. I think we can get all of the nutrients we need from animal foods in more bioavailable forms without any of the toxins found in plants. And that's a foreshadowing and a remembrance of the premise, which is that might be an ideal human diet for some people. Again, I don't believe everyone needs to eliminate all plants from their diet. But if we consider the fact that these chemicals may not be good for us, things start to look very differently. Here are 49 natural pesticides and metabolites found in cabbage. Cabbage. Are these good for us? Are they bad for us? Is it neutral? I think it's more likely they're bad for us. And I think it's really hard to make an argument that they're good for us, but we'll talk about both sides. But this is just in cabbage. And none of these are produced in human biochemistry, and none of these participate directly in human biochemistry. One of the greatest misconceptions that is commonly repeated is the notion that plant molecules act directly as antioxidants. And they just don't. They do not act in human biochemistry directly. They change human biochemistry by acting as pro-oxidants. We'll talk about that. But plant molecules, these 49 natural metabolites found in cabbage are not vitamins. They don't participate in our biochemistry. I believe they just gum up the gears and cause problems for us because this cabbage doesn't want to get eaten. Kale doesn't love you back. But phytonutrients are magical, right? Well, not so much. There are a number of studies that show that high consumption of vegetables doesn't really improve immunological, antioxidant, or clinical markers in subjects at risk of cardiovascular diseases. This is a series of studies that you might call the vegetables aren't really that good for you studies. These are interventional studies, not epidemiology. And they pretty clearly show that it's not an open and shut case that vegetables are good for us. In this study, which was a 4-week intervention, a low vegetable group, which had 800 grams of vegetables per week, or a high vegetable group with 5 times that amount, 4,200 grams. Remember that 454 grams is a pound. So you're talking about less than 2 pounds per week or almost 10 pounds of vegetables per week. And they included vegetables that we would consider to be powerful vegetables: carrots, Jerusalem artichoke, tomatoes, cabbage, sweet peppers. They looked for immunological antioxidant markers. No significant changes were detected in clinical, immunological, or antioxidant markers, except for an increase in the white blood cell count in the low vegetable group. Study provides evidence about the uncertainty of providing clear evidence for vegetables in modulating markers of immune function and antioxidant status. Isn't that interesting? I thought plants were magical. Further studies are needed. All right, well, let's do further studies. Is this all just a fairy tale? Are these all just unicorn farts, Sasquatch, or some others? Let's see. Effects of consumption of high amounts of vegetables. Here's another one. Oh, Same title, different paper. I put that there wrong. This study, 24 days of complete depletion of fruits and vegetables, or daily ingestion of 1.5 pounds of fruits and vegetables, or the corresponding amounts of vitamins and minerals. The level of oxidative DNA damage was, wait for it, unchanged. This suggests that the inherent antioxidant defense mechanisms in our bodies are sufficient to protect our cells from reactive oxygen species. Imagine that. Imagine if we, with the proper nutrients, presumably from animal foods, or just living what I call a radical life, and I'll get into that in a moment, could make all of the antioxidants we need as glutathione. Wouldn't that just make the idea of plant foods beneficial, like a unicorn fart? Like a fairy tale? Like a tooth fairy or the Sasquatch? I think so. Let's do more studies. Increasing the vegetable intake dose is associated with a rise in plasma carotenoids without modifying oxidative stress or inflammation. In overweight or obese postmenopausal women. Where is the benefit of vegetables? Of course, you're going to see more carotenoids because they're found in the plants, but if it doesn't modify oxidative stress or inflammation markers, are they really beneficial? Let's ask the question. What about this one? In this study with green tea extract, what we find is that since no long-term effects of green tea extract were observed, this study essentially served as a fruit and vegetable depletion study. The overall effect of a 10-week period without dietary fruit and vegetables was a decrease in oxidative DNA damage, blood proteins, and plasma lipids, concomitantly with marked changes in antioxidant defense. My goodness, what a different narrative this is. So now we have 4 of many studies, I didn't even review all of them, that show us that, wait a minute, either increasing the amount of fruits and vegetables massively in your diet or completely eliminating the fruits and vegetables in your diet doesn't result in a negative effect in terms of oxidative status, meaning that fruits and vegetables probably are not that protective from an oxidative status perspective. And in fact, this last study found there was a decrease in DNA damage. Well, if we think about plants from a totally different perspective, like they're not really our friends, they don't love us back, they're only survival foods in the first place, these things begin to make sense. Do we need them in our diet? Maybe not. Maybe they're not that good for us. Effective increasing fruit and vegetable intake by dietary intervention on nutritional markers. This is a fascinating study. And what you'll find here is intake increased significantly in intervention group compared to controls, achieving 8.4 portions per day after 12 weeks. The plasma vitamin C level increased, folate level increased, carotenoids increased, but there were no significant differences in the antioxidant capacity, DNA damage, and markers of vascular health. So what is going on there? What if, when given the proper nutrients from animal foods, you and I can make all the antioxidants we need from glutathione? Wouldn't that be radical? I think so. I think there's a lot of good evidence for it. Here's their conclusion. A 12-week intervention was not associated with effects on antioxidant status, lymphocyte, or DNA damage. Wow. Interestingly, in this study, vitamin C level in the blood increased, and their vitamin C increased from 70 milligrams per day to 270 milligrams per day, but there was no change in antioxidant capacity or DNA damage or markers of vascular health. So this one is one of my favorites because it asks us 2 important questions. Where is the benefit of fruits and vegetables? And how much vitamin C do we actually need to be optimal? We'll come back to that. What about hormesis? This is what everybody always says at this point. What about hormesis? Couldn't a little bit of poison be good for us? And I think this concept has been widely misunderstood. I think that we have conflated environmental hormesis, heat, cold, and exercise, things that we know can be slightly stressful and beneficial because of that, with molecular hormesis. What I mean by that is, why do we assume that we need small amounts of plant poisons to be optimal when the fruit and vegetable studies show us otherwise? And furthermore, would we consider cigarette smoke, alcohol, or lead to be a hormetic? Maybe not. But we have to be consistent with our philosophical views on these things. We either have to accept that polycyclic aromatic hydrocarbons, heterocyclic amines, cigarette smoke, alcohol, lead are hormetics, just like isothiocyanates, or realize that molecular hormesis maybe doesn't act the same way as environmental hormesis. So this is a slide that I'll probably skip. It's how sulforaphane affects NRF2. But basically, this is the important part, that oxidative stress induces NRF2 to dissociate from keep1. NRF2 is a transcription factor that goes to the nucleus, leading to transcription of antioxidant response enzymes. But many things can do this. Broccoli can do it with sulforaphane, but so can heat stress, so can cold, so can ketosis, so can cigarettes. Are these all the same? No, I don't think so, and I'll show you why. So would we consider these to be hormetics? No. I think there's a huge difference between molecular hormesis and environmental hormesis, because I think that when you use molecules for hormesis, they have what I would describe as a package insert. They have side effects. And when it's smoking or alcohol or lead, we're very aware of the side effects. But when it's a plant molecule doing a very similar thing and an analogous thing, we forget about the side effects, mostly because we're not told about the side effects, but there's good literature that those side effects exist, that there is a package insert here. This is just to show that smoking induces NRF2 and glutathione increase, as do polycyclic aromatic hydrocarbons from meat. Are those hormetics? Should we make a pill out of that? Someone call Rhonda Patrick. What if living a radical life is enough? This is environmental hormesis. What if swimming in cold water, getting in a sauna, are all we need to spur our NRF2 system from time to time? We could do this with things like exercise, with cold water swimming, being in a hot sun. This will create a small amount of oxidative stress without the same collaterally damaging side effects. So this is a study of the cold water swimmers in Berlin showing that glutathione goes down when you swim, but then comes back to a higher level at normal. This is a control group with reduced glutathione, and this is reduced and oxidized glutathione together. You'll see that in the cold water swimmers, their baseline glutathione is higher. After they go in the water, it's depleted. And you better believe the next day it's going to be back up here because environmental hormesis, right? So I don't really believe in xenohormesis like David Sinclair does. I don't believe that we need plant molecules to be ideal. I think all we need to do is live a radical life, which means doing the things our ancestors have always done, that you and I probably do without thinking about it, exercising, being in the sun, being in the cold. That is enough to have optimal antioxidant status. And then we don't get these side effects from plant molecules. There are a number of dark side effects to curcumin. I'll let you guys read this paper. Curcumin can induce DNA damage and chromosomal alterations in vivo and in vitro. What? Similar to concentrations reported to exert benefit. What? This is the side effect. This is the package insert for curcumin that you are never told about. It induces topoisomerase 2 mediated DNA damage. It activates tumor suppressor p53. Irreversibly modifies antioxidant enzyme thioredoxin reductase. Wait a minute. Why are you eating curcumin in the first place? Because you're treating inflammation, not at the root cause, with something that you heard was good for it, but has all these bad side effects that you've never heard about. You don't need it. Treat the root cause at the root. Don't use a plant molecule to ameliorate symptoms, and realize that all these plant molecules, everything that's going to do molecular hormesis has a side effect. Oh, someone called David Sinclair. Resveratrol reduces the levels of circulating androgen precursors. That's not a good thing. Whether you're a man or a woman, you don't want your DHA to be lower because you're eating a xenoestrogen in resveratrol. But Paul, doesn't resveratrol have benefits on the sirtuin genes? Sure. You know what else does? Living a radical life. Being in ketosis turns on the sirtuins as well. Being in ketosis changes your NAD to NADH ratios, just like resveratrol, without the androgen-reducing side effects. Be radical, my friends. Don't use plant molecules. Oh, you mean there are molecules that can have estrogenic effects in the human body, like flavonoids? Yep. Plants don't want to be eaten. How many polyphenols are there in human biochemistry? None. What about oxalates? Well, this group thinks they induce breast cancer. Here, calcium oxalate crystals induce renal inflammation through the NLRP3 inflammasome. Cinnamon and turmeric on urinary oxalate excretion? Turmeric massively increased urinary oxalate excretion to levels seen in people with genetic polymorphisms causing primary hyperoxaluria, a condition that results in systemic oxalosis, kidney stones so bad they often have kidney failure. Do we want to eat oxalates? I'm shifting gears here, but this is yet another thing that is produced in small amounts in the human body, massive amounts in plants, and doesn't really play well with our biochemistry. In this one, chronic exposure of breast epithelial cells to oxalate promoted the transformation of them from normal to tumor cells, inducing the expression of a proto-oncogene as CFOS, et cetera, et cetera. That doesn't sound good. In my book, there's a listing of high oxalate plant foods, and this is a microscopic view of what oxalate looks like under the microscope. Do you want those needles in your joints, your breasts, your vagina, any of these parts of your body? There's a whole group of women who believe that vulvar pain, that genital pain in women is related to oxalate deposition there. That sounds horrible. Could this be causing a lot of our problems? Potentially. We don't need them. They're a waste product in human, but look at how much is in turmeric powder. Now, of course, you're not going to eat that much turmeric powder. These are all per 100 grams, but 100 grams of spinach gets you a pretty big dose. And if you make a smoothie with spinach almonds and throw in some turmeric powder for good measure, you just got an oxalate bomb. What about lectins? Carbohydrate binding proteins? Well, my friend Paul Mason has talked a lot about this. There's a fascinating study in Denmark showing that those people who had the nerve that runs from their stomach to their brain, known as the vagus nerve, severed due to gastritis, had way less Parkinson's disease. It's an epidemiology study, it's observational, but why would severing a nerve that runs from the stomach and the gut to the brain result in less Parkinson's? Well, could it be that there's something in our gut that could be transiting through the vagus nerve to the brain, causing problems? Well, in this study from C. elegans, that's exactly what they saw. Dietary plant lectins transported to and affect dopaminergic neurons. What? The Brack and Hawkes hypothesis is exactly that. That something from the gut moves along the vagus nerve to the brain, negatively affecting dopaminergic neurons in the substantia nigra and other places, potentially contributing to Parkinson's disease. That is scary stuff, you guys. How about one more? Oh, I didn't include it. There's another study also done in rats and mice that shows the same thing. So, do we want to put lectins like this from plants in our body? Many other negative effects on lectins. Check this one out. Bacterial overgrowth in a phytohemagglutinin-fed rat. So what they're saying here is if you feed a rat phytohemagglutinin, which is the main lectin found in red kidney beans, you get proliferation and consistent adherent of microbial flora in the jejunum with E. coli. They're causing overgrowth. Lectins causing dysbiosis in rats. And in this study, they found that the bacterial-lectin interactions in the PHA-induced overgrowth had to do with perhaps a direct ligand to mediate bacterial adherence to or modify mucosal surface to increase bacterial adherence. What this means is that the lectin didn't interact directly with E. coli, but you saw E. coli overgrowing. It looked like this lectin, this phytohemagglutinin, interacted directly with the gut lining, probably the goblet cells producing mucus, impairing their mucus production, allowing bacteria to touch the epithelium of the gut, leading to inflammation, dysbiosis, holes in the mucus layer, bacterial overgrowth. That is a bad thing, my friends. We do not want the mucus layer to be compromised. No, not having enough fiber does not compromise the mucus layer. I'll get to that. But in this case, a phytohemagglutinin-fed rat model, it sure looks like those lectins in beans impaired that significantly. Tell me more about how beans are so healthy for you when I'm showing you evidence that they could be causing dysbiosis and leaky gut That's not a good thing. Here's an interesting study done by our friend Stephen Gundry, who I would disagree strongly with on his views on animal foods, but I agree with him on lectins. This is a case series from his office, 95 of 102 patients on a low lectin diet that was also high in polyphenols and prebiotics. Admittedly, I'm not a fan of those. 95 of 102 patients achieved complete resolution of autoimmune markers and inflammatory markers in 9 months. That's striking. Now, we can't say whether it was low lectin, the polyphenols, or the supplements, but regardless, it's a low lectin diet. So can't say for sure here. Some might say, oh, they had polyphenols, they got better. Well, I'm going to say this might have been due to the lectins being removed, but we don't know. More generating hypotheses, more testing. So let's return to this. Why use plant molecules for benefits which appear to be redundant? Why do we use plant molecules for optimal antioxidant status when we don't need them for that, if they also have package inserts and contain lots of potentially damaging molecules with side effects? Can we really say that the benefits of these molecules outweigh the risks? I'll let you answer that. I think you know where I stand. Bioavailability of nutrients is much higher in animal foods as well. Let's shift a little bit. This is a study looking at zinc absorption, and it found some pretty striking things. These are subjects eating oysters. You can see oysters here. You give them oysters with some beans, and you get much lower absorption of zinc in the body. Oysters with tortillas, almost no absorption of zinc. Do you think that phytic acid and oxalates in foods could prevent absorption of minerals? Yes. Are minerals in animal foods more bioavailable? Without a doubt. Do we need zinc to be healthy? You betcha. Bioavailability of iron, graphic from my book. Pretty good in animal foods. Significant drop off here for plant foods. This is heme iron. This is not heme iron. Tell me more about how nutritious your lettuce, corn, spinach, or soybeans are. Not so good. Really hard to get enough iron that way. Furthermore, looking at the digestible, indispensable amino acid scores, rice, boom, less than half of, or right about half of red meat, beef, and egg, and pork, significantly less bioavailable in plant foods. Anyone who says that animal foods and plant foods have the same amount of protein, gram for gram, nitrogen for nitrogen, is lying to you. James Wilkes, you are not telling the truth. I will debate you any day of the week, my friend. I've called you out multiple times. You know what's up. The DIAS is the best we have. It clearly shows that plant foods are abysmal when it comes to nitrogen availability. Animal foods are better than plant foods. That's the way it is. This is the Rotterdam study. Many of you will know about this. The relative risk of coronary heart disease was reduced in the mid and upper tertiles of dietary menaquinone. This is vitamin K2. This is the relative risk of coronary heart disease, the relative risk of aortic valve calcification. The more vitamin K2 you get, the less your risk. Where do you get vitamin K2? Animal foods. Now, the story here is nuanced. Let's go through it sequentially. Phyloquinone, K1 from plants, not related to any outcome, meaning we're pretty bad at converting K1 to K2 in our bodies. You better get real K2. And the skeptics will cry, what about vitamin K2 from natto? No one eats natto, and it's only MK7. MK7 is one of the many menaquinones, MK4 to MK11 or even MK13, but only one of them, I believe, is produced by bacteria. What about MK4 and MK6? Might those have importance? Yes. In animals, we get a full array of menaquinones. If we're eating plant-based vitamin K2, which is really only found in fermented foods like natto, we're only going to get some of the menaquinones. It hasn't been studied on its own, MK7 alone. Where is vitamin K2 in the diet of these people? It's in animal foods. Do you think anyone in Rotterdam is eating natto? No. No. Also, I'll note that 32 micrograms per day is a really small amount of vitamin K2. You can get that in an ounce of liver or less. What does it look like for more than 100 micrograms per day of vitamin K2, which is what most people eating an animal-based diet would get? How much lower would the relative risk hazard ratio of CHD or aortic valve calcification be? We'll see. Remember, vitamin K1 from plants, not associated with any outcome. Animal foods win. Animal foods are the real superfoods. Looking at the nutrients in liver, they just dwarf everything in blueberries and kale or other superfoods. This graphic is in my book. And what about all the nutrients only found in animal foods? There's all this talk about phytonutrients. What about zoonutrients? What about animal nutrients? These are really only found in significant quantities in animal foods. Creatine, carnitine, choline, carnosine, anserine, taurine, K2, B12, on and on and on. This is only a partial list. How are you going to get these nutrients if you don't eat animals? Could these nutrients be the reason that our ancestors suddenly grew massively bigger brains? I think so. Well, look at this. When you give creatine to vegetarians, they get smarter, meaning that vegetarians aren't getting enough creatine, and we know that creatine supplementation is necessary, or adequate creatine, I should say, is necessary for proper cognitive function. So this could be a reason that our brains got bigger. We had more creatine from animals, also more choline, et cetera, et cetera. This, I believe, is the reason our brains got bigger. Magical animal nutrients. These are not the stuff of fairy tales. These are not unicorn farts, my friends. This is real animal-based nutrition. In the interest of time, I will speed through these last slides. This talk is already too long. Like I said, I'm long-winded. I'm verbose. What can I say? But red meat will give you colon cancer. It'll cause your heart to explode. You're going to need it to poop and have a healthy gut microbiome. No, no, no. Red meat and cancer, as most of us know, is based on a WHO proclamation from the IARC in 2015, which was based on a extremely shoddily done analysis, which excluded the majority of the epidemiology and all of the interventional studies. I've done multiple podcasts on this. It's in my book. Trust me, my friends, links between red meat and cancer are baseless. And if that's the case, then why would a cohort study from Asia find that the more red meat you ate, the less cardiovascular disease mortality in men and the less cancer mortality in women? Is meat good for Asians but bad for Westerners? Sorry. What we're looking at here is misleading epidemiology. Fiber, no benefit in diverticulosis if you actually look at the literature, no benefit for constipation, no benefit for cancer, no benefit for obesity, and no benefit for alpha diversity. This is the all-hailed microbiome. Nope, nope, nope. Stopping or reducing dietary fiber reduces constipation, its associated symptoms. Well-known study, often quoted. In this study, idiopathic constipation. This is an interventional study. Associated symptoms can be effectively reduced by stopping or even lowering dietary fiber intake. They had 20 people in each arm of this group. The group that completely eliminated fiber, 100% resolved their constipation. Tell me again how fiber improves constipation when elimination resolved 100% of the idiopathic constipation in this group. This is a deep well of literature I've talked about in much more detail later in other spaces. It's also in my book. Diverticulosis, high fiber diet does not protect. Cancer, nope. New England Journal, little small journal, maybe you guys have heard of it. Do not support the existence of an important protective effect of dietary fiber against colorectal cancer adenoma. Multiple studies like this, a whole series of these from 99 and 2000. But what about the microbiome? You do not need fiber for a healthy microbiome, my friends. You heard it here first. Dietary fiber intervention involving fructans, beta-galacto-oligosaccharides led to higher bifido and lactose species, but does not affect alpha diversity. Does not affect alpha diversity. You could say, what about bifidobacterium and lactobacillus? Aren't those beneficial? We don't know. The Hadza, in fact, don't even have bifidobacteria. We cannot pretend that we know what a healthy microbiome is. You can't say fiber increases lactobacillus, therefore it's beneficial, because in the previous study, fiber caused constipation, and then removal reduced constipation and eliminated it completely in those people. So getting to the granular level that we think we know what can happen with a species of bacteria is fallacy. It's complete tasseography, tea leaf reading, as my friend Tommy Wood would say. And we know clearly that fiber does not increase alpha diversity. If you want a diverse gut, it's not about fiber. It's about being insulin sensitive and not being inflamed in your gut. Won't red meat cause your heart to explode? Well, clearly we know that everyone who eats a carnivore diet gets a higher LDL. Most of them do, but is that a bad thing? Well, in this data from the Framingham study, if you stratify it by HDL, what you'll see is that when the HDL is robust, correlated presumably with insulin sensitivity, there's essentially no increase in risk as your LDL rises to over 220. But if your LDL is low and you're very insulin resistant, there's a problem here. Could this be more about insulin resistance rather than LDL itself? I think so. There's a whole chapter in my book about this. I would encourage you to read it in much more detail, but I think here is the takeaway. LDL must be interpreted in the context of insulin sensitivity. To interpret LDL outside of HDL triglyceride ratios, outside of fasting insulin, outside of HSCRP is myopathy. It's myopia, excuse me. It's myopia. Could be a myopathy too if you're giving a statin, then you get a myopathy. But in this case, it's myopia. It's nearsightedness. It's an incomplete view. Don't let your doctor or any doctor do it. Know what your HDL is. Know how insulin sensitive you are. That is the context in which your LDL must be interpreted. In the book, I talk about all the reasons why LDL might go up on a ketogenic carnivore diet or on a diet with higher saturated fat. Not necessarily a bad thing. There are no clinical studies with a carnivore diet except this one very long study done many years ago, which is quite fascinating. And I'm saying there are no clinical studies with a carnivore diet facetiously because there are clinical studies now with a carnivore diet. This is our friend Villemar Stephenson, who lived on an exclusive meat diet for 1 year and did great. None of the measures were problematic. There were no vitamin deficiencies. There was no evidence of kidney problems. And they thrived for a year. So they were observed very closely in Bellevue Hospital for a year. Very few experiments are done, my friends, on diets for a year in a controlled setting like this. It's pretty darn safe. Many of us in the community have been eating a carnivore diet, animal-based diet for 2 to 3, 4, 5 times this, 10 times this, and seen no problems. Carnivore diets are safe. But aren't we killing the planet? Well, don't believe the hype, my friends. This is EPA data, the Environmental Protection Agency data from 2016. Livestock accounts for 1.9% of US greenhouse gas emissions. Transportation, 26.4, industry, 21.3, electricity, 30.3. You tell me who the villain is. But Paul, how can all the vegans, how can everyone say that cattle are causing as much emissions as transportation? Because they are using faulty FAO data that does not compare actual life cycle analysis of cows to life cycle analysis of tailpipe, of life cycle analysis of fossil fuel emissions. They are using data that is faulty, it is flawed. This is apples to apples. This is the actual emissions from a cow to the actual emissions coming out of a tailpipe. No one has done a life cycle analysis on the carbon dioxide emissions from transportation. It's never been done. And everywhere across the world, people are parroting information that they don't understand. When you compare apples to apples, the emissions from cows, which are part of a carbon cycle, which has always been happening in the world, and are not new carbon emissions, are a fraction of the carbon emissions of transportation. Understand this data before you parrot it. If you believe cows are contributing to climate change, research this, look at the FAO data, understand what a life cycle analysis is, understand what tailpipe emissions are, and make sure you're comparing apples to apples and understand how you are being misled, my friends. And also understand that regenerative agriculture is carbon negative, meaning that when you raise animals on the soil, you increase the quality of the soil. That soil is rich with organic matter. It sequesters more carbon dioxide. They are carbon negative. Greenhouse gas emissions per pound of carbon produced, white oak pastures is negative, carbon negative based on life cycle analysis. Look at this, soybeans, Impossible and Beyond Burger are producing more carbon net emissions than regenerative cows. Tell me more about how cows are destroying the environment. This is White Oak Pastures. Hopefully we'll do a gathering there in October of this year. This is my friend Will Harris. Regenerative agriculture allows animals to exist on the land the way they have for millions of years. In 1850, there were 250 million ruminants in the United States. Were they contributing to climate change? No way. The burps go into the atmosphere, they become CO2, which gets fixed into plants, which the animals then re-eat. They poop and pee on the ground, and that creates fertile soil, which sequesters more rainwater and prevents runoff and sequesters more carbon. That is an ecosystem, my friends. That is how animals are meant to be raised. At White Oak Pastures, they've been regeneratively farming for 20 years, and you can see that the amount of organic matter in the soil goes up substantially. Every 1% increase, I believe, is 25,000 gallons of water held per hectare of water, which decreases runoff and much more carbon sequestered, many more plants that feed the animals and feed us. This is what it's all about: soil quality. Monocrop agriculture depletes the soil of nutrients, creates runoff, and is destroying our planet. How are plants produced? Monocrop. Animals on the land is the answer for regenerating our ecosystems. Let's wrap it up here. Humans evolved as hunters. Eating animals made us human. Plants are jerks. Not really. They don't want to be eaten. They're just trying to exist. Maybe in a pinch, you can eat some plants. I'm not saying everybody needs to be a carnivore, but if you understand that plants have a spectrum of toxicity and understand which plants you may not do well with, you will thrive as long as you make animals the center of your diet. Phytonutrients are magical is a fairy tale. Animal foods are incredibly nutrient rich, tons of bioavailable nutrients. Eating animals will not give you cancer or cardiovascular disease. You do not need fiber to poop. I had a golden poop this morning. As I said in the beginning, these are many deep rabbit holes, all of which could be a 3-hour lecture. And let's return to the postulate. Animal foods are the most nutrient-rich foods on the planet. They're very highly bioavailable. They're much more bioavailable than plant foods. Remember the zinc experiment with oysters, beans, and tortillas. And they don't contain toxins or anti-nutrients. I'll let you decide what the optimal human diet consists of. And I wish you all a very happy night, a very happy day. And I hope that you will check out my book. If you debate the things I've said, then I welcome the criticism and I welcome the conversation. The reason I do this is because I think there is a lot of bad information out there that is harming people. We should not fear animal foods. They do not need to be the entirety of your diet, but understanding that plant foods exist on a spectrum of toxicity, I believe will make your life better. You don't also need to be keto all the time. Listen to my recent stuff, my recent podcasts, including some sources of animal-based carbohydrates like honey in my diet that have been very interesting. It's not dogma, it's results. So understand which foods nourish you the best. You don't have to eliminate all plant foods, but eliminating the most toxic ones will allow you to be carnivore-ish, animal-based, and I believe that will make you thrive. I believe that is the ideal human diet, but I welcome conversation about this. Thank you so much for your attention. You want to be radical? Eat nose to tail. We didn't talk about organs. This is me, Carnivore MD, carnivoremd.com, Fundamental Health Podcast, carnivoremd.com, at carnivoremd on the socials. The Carnivore Code is the title of my book. Go to Amazon, wherever books are sold. Whenever you listen to this talk, pre-order the second edition. It comes out in August. First edition was out. You missed it if you don't have my book yet. But audiobook, print, ebook, out in August. Love you all. Be radical. Thanks to the organizers of this conference for sharing their opportunity with me to do this. I love doing this kind of thing. I hope you all enjoyed this talk, and I welcome your feedback. Reach out to me. I can't wait to see you all next year in person, my friends. Take care. Stay radical.
So, Peter, that was a mile a minute of information coming in there. And did you have any idea that Paul Saladino actually used to be a vegan?
No, interesting, isn't it? And it seems to be a lot of people, ex-vegans, who finish up being carnivore. I mean, is that just their extremist personalities, do you think?
I don't think so. I mean, a lot of people, they do vegan because they're searching for answers with regards to their health, and I think it's a logical extension. If the vegan diet doesn't help you, then obviously the journey continues.
One of the things I liked about the talk was this concept of carnivore-ish. I'd never heard of that before, where saying that you don't really have to be strict carnivore. Not everyone has to be strict carnivore, and that's a concept I like, because I think there's no one diet for every person. I think we're all different, and we all have different toxicities to different plants. So, what are your feelings on the carnivore-ish diet?
Well, I really like it because it brings in this concept the problem with diets is not necessarily what's missing from the diet, but rather what's already in it. And I'll give you an example. So, we have lots of patients come in and they'll ask, what supplement can I take? What else can I add to my diet to make it better?
Yeah.
Rather than actually looking at your existing diet and saying, well, what is in my existing diet that may be actually the cause of my problems? And it's not that there's any magical supplement out there that can neutralize that. And I think Paul did a great job of going through all the potential plant toxicities such as lectins and oxalates and so on and so forth. And I think that's a good way of approaching it. We don't have to, it's not an ideology against all plant foods per se, but I think his approach really seems to be about identifying the ones which are perhaps the most deleterious and targeting those.
The other thing I found interesting was the brain size. You talked about how the brain size had increased as we ate more and more meat, but the interesting thing was the little drop at the end. Over more recent times, that our brain size, I think, was maximum at 1500 cc's. It's now down to 1400 cc's. Now, what's your theory on? He didn't really talk much about the cause of that. What's your thoughts on that?
Well, I mean, certainly in terms of timing of that drop, it appeared to coincide with the onset of agriculture. So I certainly think it's a nutrient-related phenomenon, and it probably relates to multiple factors. We know that iron, zinc, and a lot of these things, ketones, actually are the base ingredient for forming new brain tissue, actually, because a lot of the brain is actually made from fat. And unfortunately, this is very hard to actually get into the brain. So the ketones actually cross the blood-brain barrier, and then they get converted into the fatty substrates, which are actually used to make brain tissue. So I think it's probably just a reflection of changes in nutritional status, in the same way that we saw that the advent of hunting and was actually able to precipitate that or almost exponential increase in brain size. I think it only makes sense that if you then remove some of those particularly nourishing foods for the brain from the diet, that you'll see a drop-off.
Fascinating. I mean, the whole area of carnivore is, I mean, if you told me, 5-10 years ago that carnivore was a realistic diet for healthy purposes, I think I and most people would have thought if I was a bit crazy. But the proof of the pudding, so to speak, is there, and so many people seem to do well on a carnivore diet. All right, another fascinating talk from Paul Saladino.